Welcome to the powers of I. In this video we will attempt to develop the powers of I. Up at the upper left I have written the definition of I. I squared by definition is -1. That defines the imaginary unit I. On the right side of the screen I've written some basic rules of exponents which we will be using. The first one says x is the same as x to the 1 for any x. That is, if a number does not show an exponent, its exponent is automatically 1. And you're familiar with the other two rules. If you multiply two exponentials with the same base, you add the exponents. And if you raise an exponential to a power, you multiply the power by the exponent. Now, those exponent rules technically are just rules for exponentials with real number bases. But what we're going to do is, for the purposes of this video, we're going to assume that those rules also apply to the imaginary unit I to see what we develop as powers of I. So to begin, the first power of I we want to develop is I to the 1 power, and I to the 1 power would just be I by the first rule of exponents. We then need I to the 2 power, and I to the 2 power is -1 by the definition of I. We then develop I to the 3 power in the following way. Using rule 2 for exponents, we're going to write I to the 3 power as I squared times I to the 1. Now I to the 1 is just I, so I write I squared I, which is -1 times I, which is -I. And for I to the 4 power, again using rule 2 of exponents, we'll write I squared times I squared, which is -1 times -1, or +1. We now go to I to the 5th power. Now, these powers are going to be easier now that we have that I to the 4th is 1, because I to the 5th is just I to the 4th times I, and I to the 4th is 1, so that's just 1 times I, which is I. I to the 6th power would be I to the 4th, I squared, which would be 1 times I squared, and 1 times I squared is just I squared, which is -1. I to the 7th power would be I to the 4th times I cubed, and of course I to the 4th is 1, so that would just be I cubed, which is, and we found I cubed above, and you look at the third line there, I cubed was -I, and I to the 8th power would be I to the 4th, I to the 4th, which would be -1 times -1, which would be 1, which takes us right back to I to the 4th power. Now, if you look at the right side of all these equations, you get the results. I to the 1 is I to the 2 is -1, I to the 3 is -I to the 4 is 1. Then that pattern repeats exactly. I to the 5th is I to the 6th is -1, I to the 7th is I to the 8th is 1. And if I went and developed I to the 9th, I to the 10th, I to the 11th, and I to the 12th, all I would be doing would be repeating that pattern again. So I to the 9th would be I to the 10th would be -1, I to the 11th would be -I, and I to the 12th would be 1. And that would just go on for I to the 13th, 14th, 15th, 16th, etc. And every time I get to a 4th power of I, like I to the 4th, I to the 8th, I to the 12th, each one of those powers of I, which is a multiple of 4, always turn out to be 1. Well, we can use that to quickly generate any power of I that we want. For example, suppose I want to know what I to the 23rd is. I'll do the following. I'll take 23 and divide it by 4. 4 goes into 23 5 times with a remainder of 3. So, I rewrite I to the 23rd as follows. I to the 23rd is just I to the 4th to the 5th times I cubed. Now, I to the 4th to the 5th is I to the 20th. I to the 20th times I cubed is I to the 23rd by the second rule of exponents. Well, I to the fourth is just 1, so that's 1 to the fifth times I cubed, which is just I cubed because 1 to the fifth is just 1. Any number, 1 to any power is 1. So since 1 to the fifth is 1, we get I cubed, and I cubed, according to our rules over there, is negative I. Now the important part of the demonstration was this. When I took I to the 23rd, the only thing I really used was the remainder. I to the 23rd was exactly the same as I to the remainder. That's what always happens. So for example, if you wanted I to the 7,681 power, all you would have to do is take 7,681, divide it by 4. 4 goes into 7 once. Bring down a 3, bring down the 6. 4 goes into 36 9 times evenly. Get 0 for your difference. Bring down an 8. 4 goes into 8 twice evenly. 0, bring down the 1. 4 goes into 1 no times with a remainder of 1. So there's no difference between I to the 7,681 and just I to the remainder, or I to the 1, which is I. And you can find any power of I that way. Just take the power of I, divide it by 4, look only at your remainder, and I to this power will be the same as I to this remainder. And that concludes our section on the powers of I.